Hey everyone, today we're going to talk about systems of equations, and we're actually going to solve systems of equations. So let's talk about the definition first. So what is a system of equations in algebra? A system of equations is two or more equations that have the same unknowns, i.e. variables, and what we're going to be doing with these systems of equations is we're going to be looking for solutions. Solutions to a system of equations are what values work in all of the equations given. Has to work for all of them. And so what we're going to be working with, we're only going to be working with two equations. A system can be more than that, but for us, we're just going to be working with two. And so there are three different types of solutions that you can get for a system of equations. And in this graphic organizer right here, we show you the three types. So let's look at these. The first type of solution that you can come up with a system of equations is you can come up with one solution. Okay, you see the two lines that are graphed, because basically what we're going to have is two equations, and we're going to graph them. Okay, and we're going to use Desmos to help us graph them. The first type of solution we can get is one solution. And when you come up with one solution, this solution is going to be an ordered pair. Okay, so it's going to be an x and a y value, which is the point of intersection of your two lines that you have graphed. Okay, so one answer will work in both of the equations. One answer, just one answer works for both. And when you graph it, again, what will happen is your two different lines, which are represented by your two equations, will intersect. And where they intersect will be the answer that works in both of your equations. Okay, so that's the first type of solution you can have. You graph the two lines, they intersect. Where they intersect is your solution. Now, the second type of solution you can have is a no solution. Okay, when you graph the two lines, what will happen is, if you notice, these two lines are never going to intersect. So these lines are parallel lines. Okay, they run side by side. They're never going to intersect. Okay. And so what that means is there is no ordered pair, an x value and a y value, that will work for both of your equations. Okay. You may be able to get an ordered pair that works for one, but it doesn't work in the other, or vice versa. This you can write as no solution. The last type of solution that you can get is you graph both lines. You graph both lines, and what happens is when you look at your graph, you only see one of the line. Only one pops up, or you can only see it. Okay. So when this happens, what's happening is you graph the first equation, you graph the second equation. They end up being the exact same. Okay. And so this means this system would have infinitely many solutions. Because no matter what point you pick on this, it will work in both of your equations. Okay. So these lines are exactly the same. They're the same line. Okay. And you can also write it as, you can write out infinitely many. You can also use the infinity sign. So there are three solutions that you can come up with. One solution, if your two lines intersect, that point of intersection is your solution. No solution, if your two lines are parallel. Or infinitely many solutions, if you end up with the same line for both of your equations. Now, we're going to solve simply by graphing. Okay, that's the way we're going to solve systems of equations. There are actually two other ways to solve these. They are called substitution and elimination, but we're not going to show you guys how to do that. Graphing is the fastest and the easiest, especially now that we have access to Desmos. Desmos does a lot of the hard work as far as graphing the lines. All right, so you can do algebra, so we're going to look at that, but I'm going to show you a quicker way to do it on Desmos in just a second. But if we want to use algebra, so to solve them algebraically, what you do is you substitute the values in for x and y to find the point of intersection. Okay, so in other words, here's an example. Here's my system of equations right here. This is your system because you have two or more equations. We want to know, when we graph them, do they intersect? Are they parallel, or actually are they the same line when we graph them? So we could go to Desmos and do that, but let's say for some reason we didn't have Desmos. What you can do is, if you're looking for the point of intersection, is you can take, and this is a bit more work intensive, you can take your answer, so answer choice A, -1 is your x value, 2 is your y value, and you can plug them in. That's what they mean by algebraically. You can plug them in and see if they work. So what do I mean? Well, you take your first equation. So my first equation is, let's not use pink, let's use orange. -3x minus 4 equal to 2. And so you come over here. Let's see, do I have orange? I do. All right. And you would say -3, instead of the x, you would put -1 minus 4y. So 4 instead of y, we would put 2. And then we would simplify that and see if we actually come up with an answer of 2. So let's see, that would be 3 minus 8. So that would give me 3 minus 8, -5. That is not what we want. So this is actually not going to be the point of intersection because it doesn't work. Now, technically you should check the other equation, plug into the other equation and check. But if it doesn't work for the first, we don't need to check, because for this to be a point of intersection, it has to work in both of your equations. So then you would come over here and you would do the same for B. Okay, start with your first equation. So this time, instead of x being -1, we would plug in, let's see if I can erase this without making a huge mess. We would plug in x is 2. Okay, and instead of y being 2, we would plug in 1. So we'd erase that. Now, if this is a point of intersection, what would happen is this would work. So let's do the math. Okay, we don't know what it equals right now. So -3 times 2 is 6. -6 minus 4 would give me -10. Okay, that is not what we want it to be equal to. We want it to be 2. So we don't even need to check the other one. Okay, doesn't work. So then we'd come over to C and we'd try -2 and +1. So I'm going to work a little smarter. I'm going to make this a -2. Okay, so that would make that +6. +6 minus 4, if I do the math, actually does give me 2. All right, so this works in the first equation. So now I got to check it in the second equation, because it has to work for both to be a solution or a point of intersection for our system. So I'm going to say 3 times -2. I'm going to the second one, plus 3y, so 3 times 1. And see, does that give me this -3? So -3 times -2. is 6. 6 plus 3 is 9. Okay, that does not work. So this is not my point of intersection. It has to work in both. Now, I look at the back here, the last one. Hopefully this one's going to work, right? Otherwise, we did something wrong. So again, plug in x, plug in y. So -2 and -1, okay, and so forth. Oh, and my bad, I made a mistake, didn't I? Yep, I did. Look, where's my mistake? Did any of you catch it? Erase, erase, erase. Where's my mistake? Yeah, it's not -3, is it? This is positive 3x, so we need to fix that. So that's actually going to change everything. Positive 3 times -2 is -6, plus 3 is -3. So that one actually does work. Okay, so that's where the two lines would intersect if we graph them. Now, that's a lot of work, right? That took us a while. You had to kind of plug and chug. Okay, here's where you're going to want to use Desmos, and here's why we like Desmos. Because Desmos will graph these for us, and we don't have to do this algebra plugging in and checking. Okay, because sometimes you'd have to do it 4 times before, if the answer choice actually was D, and we'd be here a while. So, how does this work? Well, the good news with Desmos is all you got to do is type in your 2 equations. You don't have to do anything to the equations, just take the 2 equations that they're giving you. So if we look down at the next example, we're going to take y equals x plus 7 and 2y minus x equals 10. We're going to type them into Desmos and see if they intersect. Okay, and if they do, it should be one of these 4, and that's going to be your answer. It saves us from having to plug in. It saves us from having to do what they say algebraically. So also the nice thing about Desmos is you don't have to solve your equations for y. If we were using the handheld graphing calculators, the TI-84s and 85s and 83s, you actually have to solve every equation for y before it would graph it for you. So good news is we don't have to do that. Desmos understands what you're asking you're asking it to do. So everybody pull up Desmos, and we're going to type in these 2 equations and save us a lot of time and effort and work where we don't have to plug in. So pull your Desmos up because you want to type along. Make sure you can get it in there. So let's pull Desmos, and you're always welcome to split screen. Okay, you guys know I don't like to split screen. I'm just not good at it. All right, so first equation is y equals x plus 7. So we're going to type that in. Desmos would graph a line. There it is. Okay, if yours doesn't match mine, hit your home button, go to the next box, type in your second equation, 2y minus x equals 10. Okay, and if you can't see your 2 lines intersecting, zoom in, zoom out, do what you need to do. Home button works here. And all you have to do is tap it where your 2 lines intersect, tap it again, and there's your answer. There's your solution. Okay, saves us from all the work. What we didn't have to do is take -4 and plug it in for x, and 3, plug it in for y, and we didn't have to check and see if it worked in both our equations. So in other words, if we took the first equation, okay, and again, there's your answer, -4, 3. We didn't have to check and make sure that worked. In other words, y equals x plus 7. We didn't have to say, okay, instead of y, let me put a 3. Okay, and then let me do x plus 7, x right here is -4, -4 plus 7, that gives me 3, which would be equal to y. We don't have to do that. You don't have to do any plugging in algebraically. You just have to find the intersection. So again, make sure you understand what that means. That point right there works when you plug it in to the first equation. It also works in the second equation, and that's why they call it the solution to your system. Okay, so yay, I didn't have to do all that plugging in. The answer is B. All right, let's try number 2. We're going to type in 2x plus 6y equals 12. And then we're going to type in 2x minus 2y equals 4. Okay, now because they're giving me 4 answer choices, then they should intersect. Just a little common sense there. So again, you just type them in exactly the way you are given them. So 2x plus 6y equals 12. There's my first line. 2x minus 2y equals 4. There's my second line. They should intersect. If you don't see the intersection, zoom in, zoom out. Tap where they intersect. It'll put a dot. Tap it again. That is your solution. Your x value is 3. Your y value is 1. So 3, 1 is my answer. That's where my two lines intersect. So that would be D. So again, make sure you understand what you've just figured out. When you plug in 3 for x and 1 for y back into both of these equations, they both work. 2 times 3 plus 6 times 1 will give you 12. 2 times 3 minus 2 times 1 will give you 4. All right, well, let's try the last one. Give you like a minute. Type both of your equations in, see where they intersect. Where they intersect is your solution. So go ahead and type those in. See if you can come up with the answer. All right, so let's see what you got. This is what your two lines should look like when you graph. Again, if it doesn't look exactly the same, home it. Hit your home button. Okay, you want to tap where they intersect each other. Don't tap the other two gray dots. If you see those, those are just showing you some intercepts right there. Tap that. So our solution is 1, negative 1. And again, that means when you plug in x equals 1 and y equals negative 1 into both of your equations, it works for both. So we pop back over here, and so which one is correct? 1, negative 1. Be very careful. Okay. C and D are very similar. You have to pay attention and make sure you choose the right answer. So that's why we like Desmos. Desmos saves us from plugging in, plugging in, plugging in. Okay. It also saves us from having to solve the equations for y before we type them in to see where the lines intersect if they do. All right, so the other thing they're going to do is they're going to give you pictures like this, and they'll ask you. A lot of times they'll just say, what's the solution? Okay. This says identify the point of intersection if there is one. But again, a lot of times they'll just say, what's the solution to this system of equations? Remember, you can have one solution if your lines intersect and you write down that ordered pair. You can have no solutions if you have two lines that are parallel. Or if you graph both lines and you only get one line, which means they're on top of each other, they're overlapping, so essentially they're the same line, then it is infinitely many solutions. Okay. You could pick any one of those points, any points on the line, and it will work in both equations. So let's look at number 4. Clearly we have two lines. Here's the first line. And just so everybody can see them better, here is the second line. They do intersect. Okay, so we know we have one solution, so we have to write it down. So our one solution is where our two lines intersect. Okay, remember, you always start at your origin. Your origin is right here, okay, where your x and y axis intersect. So that would be, we'd go to the right 1, 2, 3. And if you have to kind of do this to count it. So right 3, so that's positive 3. And then to get to the point, we have to go down 2. So that would be negative 2. Okay, so that is my solution to that system. All right, let's look at number 5. Again, very clearly, you have two lines that intersect. Here's the first one. Here's the second one. So we know we have one solution that works in both of our lines. It's where our lines intersect, which would be right here. So again, you start at your origin, and sometimes it's hard to see, so look up here and look for your y, and look to the right, look for your x. Okay, so this is your y-axis, because sometimes people have a hard time seeing where to start. There's your y, here's your x, so we're going to start right here. That's our starting point, that's your origin. So how do we get to this point? We have to go to the left 1. Okay, remember, left is negative, right is positive. And then your y is your up or down. We have to go down 1. So if we go down 1, it's a negative 1. And that's my answer. -1 is the solution to those two equations. All right, let's look at number 6. We do have two lines. Here's my first line. And here's my second line. Right, now, do they intersect? No. Okay. So remember, if they don't intersect, they're parallel. These are parallel lines. And if you have parallel lines, okay, that means they're never going to intersect. So you'll never have a solution. No ordered pair, no matter which one you try or which one you pick, will work for both of these equations. Okay. So there is no solution. There's no solution. There's no ordered pair that will work for both of those equations of the line. All right. You try 7, 8, and 9. I'm just going to color code the lines so you can see them. And actually try 7 and 8. We'll talk about 9. I'm going to give you like a minute and a half. Okay. I will tell you both of them should have one solution, because just eyeballing them you can tell they both have one solution. So see if you can come up with, the ordered pair. And like I said, then we'll talk about 9. Okay, if you're waiting and you want to try 9, go right ahead. But right now just try 7 and 8. All right, so let's see what you guys came up with. For number 7, yes, there's two lines. Yes, they intersect. So we know we have one solution. We have to write down this point of intersection. So again, if you have a hard time, especially this is not the greatest copy, I realize, but here's your y-axis. You might want to just darken it with your pencil. Okay, find your y. That's will help you find your x. This would be your x-axis. So your starting point, your origin's right here. So you'd have to go to the right 2. So that would be positive. And then you'd have to go up 2. So that would also be positive. Okay. All right, let's try number 8. So that's your solution, 2, 2. 2, 2 works for that system of linear equations. It will work in both of the equations, if we had the equations. All right, so number 8, again, clearly two lines. They intersect. We can see the intersection very clearly right here. We want that point. Again, if you need to, here's your x-axis, here's your y-axis, just so you can see your origin. So we're going to start here. We have to go to the right 1, 2, 3, 4. Remember, right is positive, left is negative. So positive 4. And then we have to go down. 1, 2, 3, 4. Down 4, down is negative. Down is negative, up is positive. So the solution to that system of equations is 4, -4. Now, number 9, whether you tried it or not. Number 9, when I get to it, I go, huh, there's only one line. Okay, so what happened is when this was graphed, they graphed two equations, but the two equations ended up being the exact same line. Okay, so they graphed the first one, and if you'll see this happen in Desmos when you get to the practice. You graph the first one, they color-coded it, and then you graph the second one, and the second one actually ends up being the exact same line as the first. They completely overlap. So remember, when that happens, your answer actually is infinitely many solutions. You cannot just pick one. Okay. Can't pick one because they don't just intersect in one point. What it means is no matter what point you pick, okay, so I could pick this point, Miss Witcher could pick this point, Miss Yaming could pick this point, Miss Wagner could pick this point, okay, Mr. Doss could pick this point, Mr. Guzman could be up here. Okay, no matter what point you pick, because they're basically the same line, it's going to work for both. And you can see we could pick infinitely many. So that's your answer. Okay, there are infinitely many, and you probably should write solutions. Okay, we don't expect you to write all those ordered pairs out because you can't. Because lines go on forever, so you'd never stop writing. All right, so again, solving system of equations. We're only doing two equations. You can have more, but we only do two. You could have three, you could have four. It gets a bit more complicated the more you add. If they intersect, you have one solution, and you have to write down that ordered pair. If they run parallel, then you have no solution. Okay. There's no ordered pair that will work in both of your equations. And if you end up with one line, basically it's the same line graphed twice, then no matter what point you pick, they will all work, so you have infinitely many solutions.